When you scale at larger scale in enterprise environments, using that kind of pre-shared key doesn't work anymore, because every time somebody leaves the company or every time you have somebody being hired, you have to move the key again. If somebody leaves the company, you may have to change the key on all laptops. That just doesn't work. So in larger environments, the 802.11 talks about the enterprise mechanism by which you're going to authenticate each and every single user individually. So each person will have different credentials. And that makes that if somebody leaves the company, you just cancel those credentials. You don't have to change everybody else. And to do that, they reuse some mechanisms that were there before 802.11 that were just adapted to Wi-Fi. And one of the mechanisms is what we call 802.1x, which is an older protocol dating from the 1990s, by which there is what we call a supplicant, which is the client trying to get access to the network wired in those days or wireless today. And there is what we call in the middle the authenticator, or network access server, or NAS. In the early days, it was a switch to which you would plug. Today, that's your access point or your controller. And then you're a place where the authentication is going to be conducted, and that's called the authentication server. So with 802.1x, the supplicant tries to access the network via the authenticator. The authenticator is going to block the communication to the network and just relay traffic using one possible protocol, which is Radius, but there are a few others allowed by this protocol. So relaying these queries to the authentication server. This communication is going to be blocked and limited to the authentication server until the server returns to the authenticator and access accept, client is validated, you can unlock this client. And at that time, the authenticator is going to release the control and let the client communicate through the authenticator. One particularity of 802.1x is that it does not describe how the authentication is done between the supplicant and the authentication server. It just describes this mechanism by which communication is blocked until the OK is received from the authentication server. But how is the communication going to happen? Well, there is another protocol that is an IETF protocol, which is Extensible Authentication Protocol, EAP. And what this one does, it says, whenever you need to authenticate, the choreography is always the same. You knock at the door, and somebody says, "Who are you?" And you prove who you are. So because this choreography is always the same, they thought, why don't we design frame or packet headers that would be matching those different phases? And that's what EAP is about. It basically describes a header that is typical of any phase of the authentication process. The phase where you ask for access, the phase where we challenge you to prove your ID, the phase where you return a proof of your ID, and then the phase where we accept or refuse your ID. So 802.1x is combined with EAP in Wi-Fi to conduct the authentication. 802.1x to block the access through the access point until the authentication server validates your ID, and EAP just to carry the exchange of the frames between you and the authentication server via the access point / controller, which is the authenticator, and the authentication server, and carry the exchange. This is why in Wi-Fi you find very often the 802.1x / EAP processes. It's because they are combined together. We use .1x for the process and EAP for the frame choreography. So this choreography was defined in 802.11 in an amendment that came out in 2004, which is 802.11i. That allows two mechanisms. One is this pre-shared key system for small networks, and for enterprise security, they combine 802.1x and EAP together. And the way it works is that you have the supplicant, which is your laptop, the authenticator or NAS, network access server, is the access point or the pair access point / controller. And then, of course, there is the authentication server. You try to get access to the network from your laptop by sending some 802.1x / EAP request to the authentication server, and those are going to transit through the authenticator. The authenticator is not going to care so much about how you're going to authenticate. What it's going to do is translate your queries, which are 802.1x / EAP type, into Radius language to forward them into the authentication server. And then at some point, the authentication is going to happen between you and the authentication server, with the authenticator in the middle just relaying traffic from 802.1x EAPs to Radius and back. And at some point, if everything works well, you should get an OK from the authentication server, and that access accept is going to be sent to the authenticator, and then your access will be granted and you'll be able to access the rest of the network. The great thing about this mechanism is that once you authenticate each and every single device, you can take advantage of that authentication phase to also generate a key that is going to be unique to that device. And you see, that means that with that kind of security, each and every single laptop, each and every single client has its own key. No pre-shared key anymore. So it's a lot more secure. You cannot just grab the key and get in. You have to be authenticated to get a key. That key is called the pairwise master key, or PMK. The great strength of this mechanism is that, in fact, the key is never going to be transmitted between the client and the authentication server. What is going to happen is that after authentication is completed, they will agree on a secret that will be used on each side to derive that PMK from the authentication process. So the authentication server is going to derive the PMK, and at the same time, with the same mechanism they agreed on, the client is going to derive the PMK. So at some point, the authentication server and the supplicant will have the same PMK resulting from the client authentication. The authentication server is going to send that PMK to the controller, but that's over the wire, over a secure connection. So the controller and the access point will have the PMK, but the PMK is never going to travel over the air, never. So nobody can eavesdrop that communication and capture the key because it's never sent. Whenever you use this mechanism, this enterprise security, authentication has to occur. So you can use the Redis server as a source of authentication, and the Redis server itself can rely on some Active Directory or other LDAP database to authenticate the client. So the controller would be subcontracting to the authentication server that authentication phase. But in smaller networks where you want that enterprise security, but you don't have an external Redis, you can also activate a sort of Redis function on the controller, which is called local EAP, in which case you will ask your controller to act as a sort of mini Redis. I say mini because it doesn't have that many options like a real Redis would, but enough to authenticate devices. And then the controller can use its own database to check for your username and password, and it can also use some other databases, for example, an external LDAP server or Active Directory.